The third presentation session will begin shortly. Please have a seat. The third presentation session will begin shortly. Please have a seat. Lots of inspiring ideas have emerged from the last two sessions. In the following session, we would love to focus on environmental protection again. The first presentation team of this session comes from Concordia Middle and High School. They're going to talk about promoting and accelerating development of environmentally sound technologies in Taiwan. Please give them a big round of applause.
Good afternoon, fellows. We are students hailing from Concordia High, and I'm Cece.
I'm Willie.
I'm Wendy.
Today, we're going to discuss promoting and accelerating the development of environmentally sound technologies in Taiwan. For the start, we're aware of increasing severity of global environmental problems, and also believing that the transfer of and development of environmentally sound technologies are the key to solve environmental problems. And we hope to establish comprehensive system and keep human beings aware of this essential issue. I'm going to clarify the definition of clean energy by UNEP now. Clean energy is energy derived from renewable, zero-emission sources which do not pollute atmosphere and environment. And it also includes energy saved through energy efficiency measures of energy efficiency appliances. And clean energy not only helps protect the environment by reducing greenhouse gas emissions, GSGs, but also offers economic benefits, health improvements, and enhanced energy security. So here's the total energy supply in 2021 of Taiwan. The coal stands for 35%, and the oil stands for 35.7%. Also, the natural gas stands for 21.1%. But however, there's only for 2.3% clean energy use rating for Taiwan. And now I'm going to introduce the 3 clean energies of Taiwan: wind energy, solar energy, and hydroelectric energy. For the wind energy, as of 2023, Taiwan's wind energy capacity stands at approximately 2.5 gigawatt, with 1.5 gigawatt onshore wind farms and 1 gigawatt for offshore wind farms. And the government has implemented that competitive feed-in tariffs, subsidies, and streamlined regulations. But however, there are some problems. While the sector faces challenges such as typhoons, grid integration, and environmental concerns, and it makes loud noises underwater and onshore. Taiwan aims to reach 5.7 gigawatt of offshore wind capacity by 2025, and supported by ongoing technological and infrastructural investments. The second one is solar energy. And in Taiwan, there's increased its solar power capacity to approximately 10 gigawatts by 2023. And it's supported by the feed-in tariffs and subsidies. Also, they build large-scale farms, rooftop installations, and floating solar projects by this. And the government aims to reach 20 gigawatt capacity by the 2025. The last one is hydro energy. These 3 clean energies, this is the least one, but however it's important. The capacity was 4.6 gigawatt, and making it a significant component of the country's new renewable energy portfolio. The government's efforts focus on maintaining and upgrading existing hydroelectric plants. For example, there's developing small-scale hydro projects on the ocean also. And however, there's also problems for environmental concerns. And the sectors face challenges by limited suitable locations for new large-scale projects and variability of rainfall patterns, which can hydroelectric output be impacted. And let's welcome Willie to give us a talk about the smart grid, and it is one of our ESTs.
Thank you, Cici. And I'm going to talk about the smart grid, and we organize it into 6 parts. First is immediate monitoring and control. It has the operation status of the sensor and intelligence equipment joint system. And it also collects and analyzes data immediately to find and solve problems in time. Sorry? Okay, second, it's two-way communication. It has two-way communication between the grid operator and the user, can obtain the user's electricity data immediately. Third is automation. Automated equipment and systems can automatically carry out power stunning and fault handling. Fourth, energy storage technology. It integrated battery and energy storage system to balance power supply and demand. And second, it stores excess electricity and releases it during peak demand. Sorry. And the fifth one, demand response. It adjusts the user's electricity demand according to the power supply and demand situation. And it guides user to use electricity during low peak hours and reduce peak load through price incentives. The last one, renewable energy integration. It supports the access and merger of renewable energy, such as solar and wind energy. It optimized the application of renewable energy and balance power supply and demand. Let's welcome Wendy. She will introduce Taiwan's Climate Change Response Act.
Thanks. Our first key point today is the goal of net zero GHG emissions by 2050, as stated in Article 4. Taiwan aims to implement measures across all sectors to achieve this target. This involves the development of negative emissions technologies, such as carbon capture and storage. Additionally, Taiwan will collaborate with international partners to reach these ambitious goals. Next, we have the climate change response principles outlined in Article 6. These principles align with both national and international targets to emphasize cost-effectiveness and just transitions. Taiwan will foster scientific research and innovations, establish green financial mechanisms to fund climate change actions, and enhance its international competitiveness through sustainable practices. Moving on the action guidelines in Article 9. These guidelines are developed by considering economic and environmental context. They will be reviewed every 4 years to ensure they remain relevant and effective. Importantly, these guidelines will be made public to maintain transparency. Article 13 of the Climate Change Response Act mandates regular surveys, statistics, and annual reports on emissions. By tracking the growth in installed capacity from 2015 to 2020, we can observe the increasing efforts to transition to cleaner energy sources as part of our emission reporting requirement. Article 17 is about building adaptation capacity. This involves promoting reliance, conducting scientific assessment, and improving disaster response. Sustainable development goals will integrate it into policies with collaboration between public and private sectors. Additionally, there will be education and support for volunteer groups. Article 23 and 24 set performance standards and require emissions offsetting. Specific standards will be established for products, vehicles, and buildings. New or modified emissions sources must offset increased emissions or pay monetary sum. Article 29 and 38 are with voluntary reduction plans and restrictions on high global warming potential GHGs. Entities that propose voluntary reduction plans can qualify for preferential carbon fees. Additionally, there are restrictions on use of high GWP GHGs. Finally, Article 42 and 44 emphasize public awareness, education, and energy conservation. Climate change education will be integrated into school curriculums. Sustainable practices will be promoted among the public, and efficiency will be encouraged by suppliers and distributors. And let's welcome Willie to talk about some tips we can use in our life.
Thank you, Wendy. And this is kind of solution that we have come up with, and we can execute these steps into our life and to help Taiwan gain 2050 net zero emission. First, conserve energy. We can use energy efficient appliances and LED light bulbs. Okay, I will briefly go through it. And next is reduce waste, and also sustainable transportation. Change our diets. Support renewable energy, and planting greenery. And the last one, raise environmental awareness. Let's welcome Cici. She will give a brief conclusion towards our presentation.
Okay, so through this research, we get in touch with many aspects of Taiwan energy use and the issues behind. We're hoping to resolve the substantial issues nowadays, and the lack, the waste of energy use, they're both problems, and we want to revise the acts, policies, and infrastructure of Taiwan use of the resources. Within the acknowledgements of the ESTs, we just introduced like smart grids. We aim to achieve the goal by clarifying the SDGs potential targets Taiwan possess. This is the end of our presentation. Thank you for listening.
Thank you, Concordia Middle and High School, for your sharing. Next, please welcome Kaohsiung Municipal Kaohsiung Senior High School. The topic of the presentation is Wind Power Soars, the sustainable wings of SDGs Flourishes through wind turbines.
The topic of our presentation is wind power source, the sustainable wind of SDGs furnished wind turbines. Firstly, we will focus on SDGs 7.2. It means sustainably increase the share of renewable energy in the global energy mix. And now we will provide an explanation of the lecture we used during our reach point. Firstly, from the charts, we can see that fossil fuel currently accounts for 72% of the global energy structure, while other renewable energy sources make up a smaller proportion. However, their share has been gradually increased each year, reaching 20% by 2018. Next, let's discuss hydro generation. From the chart, we can see that it accounts for about 8%, which is higher compared to another green energy. We believe this due to its relative well expectation development. Next, let's take a look at bioenergy and waste-to energy. From the chart, we can see that it accounts for about 50%. Finally, let's discuss the current energy source, wind power and solar power. The green part in this chart. Although they currently represent a smaller proportion, it's evident from the charts that they are repeat increase. We believe the growth is due to the repeat development and improvement of their technologies. That is why we have chosen to focus our research on this on wind power energy. Next, we will outline Taiwan's energy policy. First, green energy expansion. Second, increase the natural gas. Third, cost reduction. And fourth, non-nuclear focus. Lastly, we will discuss the evidence of wind power generation in Taiwan. First, from the generation perspective. From a generation perspective, Taiwan is located in a subtropical region which provides abundant wind energy, especially among a western coast. Here. And in the eastern mountain area. Furthermore, from an economic standpoint, development the wind power district can create job opportunity and attract investment and improvements economic growth. And look at the charts on the right. Taiwan has long relied on import energy sources like natural gas. And so wind power become a key to deal with the problem. It can diversify its energy source, thereby reduce its dependence on import energy. Finally, looking toward future developments with advance in technology and decreased cost. Wind energy technology is become more mature and feasible.
Okay, next, let's talk about the process of making wind turbine and solving the problems. Before making wind turbines, we need to understand these scientific principles. The first is lift force. We can design blades that generate maximum lift based on these principles. The second is best laws. This principle says that even the best wind turbine can only capture a maximum of 59% of the kinetic energy in the wind. The third is power coefficient. We can use it to measure the efficiency of wind turbine. Next, manufacturing process. The first step is data collection. We made a simple wind turbine and measure the blade's angle that produce the best output power. It serves as a guideline for future production. And then we shape the blades using aircraft wood as the material. And for the structure, we use woodworking techniques. And for the transmission system, we use 3D print to produce gears. But during the production, our biggest problem is that we are unable to precisely shape the blades. But however, we overcome it through a computer-aided design. First, we drew the unshaped blades model on the computer and plot curves on the blades model. We also use airfoil resources from the internet and imported airfoil data into the computer. Finally, we use a laser cutter to create templates and then use it to draw line onto the unshaped wood. This allows us to precisely shape the blades by following this line. Finally, we made the 3 generations of wind turbines. The first generation had an output power of 125 milliwatts, and the second had 1,400 milliwatts, and the third generation had an 1,867 milliwatts. The significant improvement in the third generation was due to using the computer-aided design and the addition of 2 more blades. But in terms of sustainable development, what was the cost of this wind turbine? The average cost of the wind turbine we made is about 2,800 new Taiwan dollars. If we use third generation wind turbine to charge a small power bank, it would take 13 hours. To charge an electric bicycle batteries, it would take 15 days. It is obviously that the wind turbine need to be further improved during the cost, including the cost and efficiency. So, we propose the following future outlooks. By learning more advanced knowledge and techniques, at the same cost, the wind turbine quality can be further improved to increase power output. Second, in the future, with mass production, the cost will inevitably be driven down. Third, it is a necessary investment, as the cost will naturally be high before the technology matures. But how can we achieve this? So we propose the following future outlooks. Let's understand the current wind power development in Taiwan first. The wind power knowledge is too specialized, often requiring advanced education to deeply make a research in this field. This result in the lack of professionals in Taiwan and a reliance on imported technology. So, in the future, we can promote wind power knowledge or wind turbine hand-on courses in elementary, middle, and high school. This way, students can develop a basic knowledge in wind power energy from a young age and may become interested in the field. Like us, through hands-on project, we made wind turbines. We can thus better understand the limitation and advantage of wind power technology and propose concrete solutions in scientific or social aspects. Additionally, the government is already investing in the wind power industry, but we believe the cultivation of professionals is even more important. By training professionals and having our natural environmental advantage, we can develop wind power technology independently, thereby getting closer to SDGs 7, affordable and clean energy. This is all our representation. Thank you for your time.
Thank you, Kaohsiung Municipal, Kaohsiung Senior High School, for your wonderful presentation. For our next presentation, we have a team of students from both Kaohsiung Municipal, Kaohsiung Senior High School, and Kaohsiung Municipal, Kaohsiung Girls Senior High School. Their presentation title is Study on the Performance and Optimization of Paper Batteries.
Hello, everyone. We are from Kaohsiung Municipal, Kaohsiung Senior High School, and Kaohsiung Municipal, Kaohsiung Girls Senior High School. Okay, I'm Wang Xianting.
I'm Liu Zhiling.
I'm Zhou Wengxiang. And I'm Cai Wenkai.
First, I will give an overview of our study. Due to its comparative environmental benefit and applicability in various fields, zinc air batteries have gained a promise as a potential method for energy storage. We were inspired by a simple demonstration in a chemistry class. When a battery was assembled from everyday materials like plastic, while we were amazed by its simple construction, we also recognized its potential to create cheap and effective energy storage solutions. Our motivations also stems from the urgent global imperative to transition towards sustainable energy source and storage. By utilizing these batteries and applying them across various fields, we aim to contribute to the UN's Sustainable Development Goals. Second, I will discuss our field of study. Our main focus was to develop a battery with accessible and eco-friendly components. To optimize our battery's performance, we conducted various experiments on its output voltage and investigate encapsulation techniques, as well as other related parameters such as energy density and cycle life.
Okay, next, we will talk about the development of thin air batteries. As we can see in the slide, the thin air battery use a thin anode and the air cathode with aqueous alkaline electrolyte. The electrolyte usually use the potassium hydroxide. And we can see the key reaction here. The thin turning into thin oxide at the anode and the oxygen participating in the cathode. Let's talk about material improvement in thin air battery. We can see the anode and adding the bismuth trioxide or the indium trioxide to prevent the dendrite formation. Moreover, we can use porous anode, the thin anode, and multiple layers to increase the surface area and make it more and gain the performance. Next, we will talk about the electrolyte, the ionic liquids for better stability and conductivity. And using the mini dioxygen and tricobal tetraoxide to improve oxygen reduction, reaction, and oxygen revolution reactions. The image shows the type of the reaction, the materials, and the voltage levels for different pH environments. And it highlights the relationship between the electrolyte, electrode, and their redox couples. To compare the performance between thin air batteries and others, we can use energy density, power to weight ratio, and energy to weight ratio. And we can see in the table, the thin air battery is better than than other batteries in this table. Regarding the pollution, we can see the thin air batteries require fewer materials and avoid harmful substances like sulfuric acid and heavy metals and makes them less pollution and recyclable. By the way, this is also the reason why the thin air battery is cheaper than other batteries in this form. Based on our previous statement, the thin air batteries offer advantage like low cost, high energy density, and environmental advantage. And it aligns the SDGs 7 and 12. Our experiments use the carbon piece, the conductive tape, and the carbon piece to lightweight the batteries and makes it cheap, easy to produce, and more compact.
After that, we'll talk about the reactions happening in our batteries. So after some experiments, we deduced that there are mainly two reactions happening in our batteries. So for the first reaction, during the charging process, the zinc ions precipitate as zinc, and the water releases electrons and oxygen. And during the discharging process, the inverse reaction happens. As for the second reaction, which only happens during the discharging process, the zinc turns back into zinc ions, and the hydrogen ions react with the electrons to release hydrogen gas. So we can summarize these two reactions and then use the Nernst equation to try to predict our battery's performance. Next, we'll talk about how we derived our reaction processes. So for the first reaction process, at first, we try to change the electrolytes in the battery and notice that zinc sulfate as the electrolytes performed better than other electrolytes such as sodium chloride. And we decided that it may be due to the zinc reacting with oxygen in the air. So we made a battery with the cotton piece removed, and after prolonged charging, we noticed a lot of zinc precipitating near the electrodes. After that, we also made a packaged battery, which showed significantly better performance than batteries that were not packaged, which we concluded to be due to the increased oxygen concentration in the battery itself, proving our hypothesis. As for the second reaction, we simulated our battery's environment by dipping zinc and carbon rods into a sulfuric acid solution, which outputs some voltage, and bubbles also came out near the electrodes. After that, we conducted a series of experiments to try to investigate key parameters that may optimize our battery. So for the first experiment, we changed the concentration and noticed that higher concentration generally gave better performance. But the concentration only affected the initial voltage slightly. And if we plot the theory against our experimental results, we can see that it actually roughly matches up. After that, we changed the quantity of the electrolyte. So we performed two experiments. In the first experiment, there was only one layer of the cotton piece, but we applied different amounts of the electrolyte onto it. And in the second experiment, the same amount was applied onto each piece, but we applied different numbers of layers of the cotton piece onto our batteries. And so the result is that first, quantity only affects the initial voltage very slightly, but that the larger quantity also prolongs the voltage output time quite significantly. Finally, we changed the size of the cotton piece and found that it performed best when the cotton piece was at 3 by 5 centimeters. And we concluded that it was probably due to the larger contact area between the cotton piece and the electrodes relative to the cotton piece.
So based off the above, we draw this conclusion. First, battery performance can be estimated with the Nernst equations. And second, higher concentrations leads to prolonged voltage output. This is because the battery is able to high potential difference between the electrators as long as the reactant concentrations is high. And this is increasing voltage can be maintained for longer, extending the voltage output, resulting in more consistent and longer, better power delivery. Third, the larger quantity of the electrolytes leads to prolonged voltage output. As the electrolytes in batteries facilitate the flow of ions between the electrodes, and large amounts of electrodes ensures that there are enough ions to sustain the reactions over time. And the last point, larger contact area of the salt bridge leads to prolonged voltage output. Salt bridge in galvanic cells maintain electrical neutrality by allowing ions to flow between the two half cells. After improving the salt bridge contact area, the larger contact area enhances its ability to effectively transport ions and reduce internal resistance and prevents charge accumulation. Finally, that's our future work. And first, one, controlling the acidity of the electrolytes. By carefully adjusting the acidity of the electrolytes in the battery, we can observe and analyze its impact on performance. And second, develop charging and discharging algorithms. Using artificial intelligence, we are developing charging and discharging algorithms to maximize the performance of our batteries and prolong its lifespans. And the third one is integrating other sensors. By using an MCU unit with advanced sensors, we can accurately measure battery energy density with our other key parameters. And there's our report. Thanks for your attention.
Thank you for all your presentation. All 11 presentations for today have been delivered. We are honored to invite our professors to provide valuable feedback for presenting teams.
Okay, thank you, section 3, the 3 group. Okay, so let's welcome the Professor Xie from the Taiwan University to give the comments. Let's give applause to welcome the Professor Xie.
Okay, I would like to give comments on the final presentation, the paper battery, okay, from the Kaohsiung team. Okay, I think it's a very good scientific-based research, okay, because you design a very simple battery structures, okay. However, you can study lots of parameters, okay, one at a time, including the concentration, the number of the cotton pieces, you know, the concentration of your sulfide electrolyte, etc. So it's a very systematic and well-documented research. I think that's the basics of doing experiments. Okay, is to document, to observe, to document, and then to elaborate on the results. Okay, so I think that's one of the most rigid and systematic works. Okay, I heard today. Okay, so congratulates on the efforts. Okay, and also I would like to sort of suggest that for the battery researches, okay, it is especially under the topic of SDGs, okay, you have to also consider the broader aspect of like water pollutions and how much water resources you're going to use, and also the recycling of the electrolytes, etc. And okay, so that can be done, okay, as a supplementary study, okay, to accompany the scientific, the chemistry, okay, the electrochemical research, okay. It can be a nice accompanying studies, okay, to talk about the recycling aspect, okay. I think that's what the ideas of SDGs, okay, it's not to only to produce the device, but also to consider the materials you're going to consume and how you're going to recycle each component, okay. I think that can be something for you to think about, okay. How can you bring a broader view, okay, into your research? I like the research very much because it is like a multi-scale, okay. So it starts from you introduce the chemical formulas, okay. I like that a lot, okay, because that's what scientists like to see, okay. And then you sort of explain the results and produce lots of interesting comparative, in terms of parameters, okay, how they compare each other and whether they fit the theories, okay, or the theoretical prediction or not. Okay, so I think overall it's a good presentation, and I also like I like the way you present, okay, without looking at the notes and to do it, okay, to walk around and then to integrate your talk, okay, with the slides, and then to make eye contact. As one of our professor mentioned, okay, earlier, that you have to make eye contact and to show confidence, and it's not about how well you speak the English, but it's how engaging you are, okay, to your content and to the slides and to the audience. So again, I would like to praise your effort. Thank you.
Thank you, professors, to give a comment to the third group, the Kaohsiung Senior High School and the Kaohsiung Girls Senior High School. Next, we sincerely invite the Professor Wang, and let's give applause to welcome the Professor Wang.
Yeah, thank you. So following the Professor Xie's comment, I have the similar observation, especially for these three groups. And I think I will focus on the group 1 and about the environmental sound technologies in Taiwan. So where's the group 1? Okay, yeah, here. I think all of your English presentation abilities are pretty nice, and also no matter the pronunciations, and also I think all of you have the several years learning English, even from the native environment. So it's much better than mine, I would say. And but for the talks, what you get, I think normally when people are reading the paper form, you can get more information compared with the talks. But for your part, it's inverted. Okay, so that means I will suggest probably you can rethink about what you want to. If you have another chance, or if you have another week, and what you can improve about your paper font, because I think all of you really try to touch the very important question, no matter in Taiwan or in the global wise, right? And also, I think the future, the next 10 years, 20 years, it will go for these directions. But because I think the reference 1, you try to read the National Development Council's report, because that is a report from the national level and the national view, try to make a conclusion about the energy development policy from the nations. But I think you can help us try to digest all the information and try to present something really what we should learn, or what your suggestions. It's not just follow the report. So that is a very seasonally suggest I will give your group. And because few of those slides even with contain the figures, right? But there's no any one figure from the report. That is quite, I think, something you can improve part, okay. And so again, I really love the topic what you try to really do, because even for me, I never have the chance to really read through the national report from the National Development Council this part, because I'm sometimes really join some other councils to even the wind power part or the wind farm, the ability part. Why is that is the environmental sound? Okay, because for me, I'm the biologist. I try to help our nation to really detail to check all the technologies or all the companies what they use. We try to not really the judgment guys, but we try to help our nation try to go through this direction by more, I will say, more environmental contents. Okay. So again, thank you for your presentation. Thank you.
Thank you, Professor Wang, to give the comments to the group one. So next one, we are going to invite Professor Liu to give the comments to the group two. Let's give a applause to welcome the Professor Liu.
Thanks, Chairman. As the final reviewer, I think I have the privilege to introduce myself why I'm here. The topic about the group number 2 is related to the wind turbine. I can tell you I'm from Department of Civil Engineering. Can you imagine? Wind turbine is part of the structure, and this issue can be dealt with in our department. So that's the reason I think in the beginning, Professor Chai invited me to be a reviewer. In the beginning, I was wondering, can I deal with so many different topics? But at least I find it something I can show you my experience, just like this wind turbine. Again, wind turbine is a very hot topic issue right now in Taiwan. People always want to improve the electricity efficiency by using the wind power. And the group number 2, you use the test to verify your models. You have generation 1, 2, and 3. So you want to prove your design is very efficient. But during the process, maybe I can let you know there is an organization in Taiwan. They organize the wind power competition. I don't know whether the group number 2, can I know where are you? Okay. Do you know the kit wind test competition? Maybe some of you already learned that. Yeah. So that is a very well-known and very high standard competition, not only in Taiwan. You can, if you can be the winner in Taiwan, you can be a representative and join the competition in USA. The reason why I asked you to participate in this kind of test is you will know what is the standard. The question for your topic here is you don't have a very, I don't know what is your standard. You just want to generate the electricity as high as possible. But if I challenge you every details, probably you cannot pass my examination. For example, how you design the blade, what kind of generator you use, how fast is the wind speed you blow. So every details, what I want to say is, if you want to study this topic, try to find some organization with the standards. Otherwise, you did this test. Another group did the same test, similar test, but you cannot show your excellence. Okay? Maybe you think your model is good, your wind turbine is good enough. But if you put in another group, probably you will be a failure. So try to join the competition if you have time. I don't know whether before your graduation you have time or not. Yeah, so what did you learn from the test, from the competition? Yes? Yes? Yeah, so you know the theory, and there's another thing maybe I can emphasize, how you connect what you have learned in your class and the experiment and the competition. You know the theory, but how to use this theory to build up your model, right? So I'm glad you already joined the competition and learned something, so you will know the standards. Otherwise, people will say, okay, I know you have your model, but how good it is, we cannot quantify. How to quantify that? Right? That will be the problem. Any team like this similar approach will face the same problem. But at least you finish the experiment and prove it is possible. And the final thing I can remind you, if you really want to study the wind turbine structure, I will encourage you to join NCKU. Not because I'm the associate professor from the Department of Civil Engineering, because we have a very, it's a very hot topic. In NCKU, we have Department of Civil Engineering and Hydraulic Department. We can let you know every details if you really want to build up your own wind turbine. Then your dreams flow. Okay, thank you.
Thank you, Professor Liu. Because all of you are very excellent, so Professor Liu start to recruiting the students you come to participate in the NCKU. Okay, so in my opinion, I do think the group 2 is doing very good because they use their hands to build up the wind turbines by themselves. And it's also very clearly described all the manufacturer's process, so it's good, okay. But I still have one reminder to the suggestions to the group 2, and this suggestion is also for everyone here, okay. Because in the group 2, in the your presentation about figure 1, when you're talking about the trends in the global energy supply from the 1990 to the 2018, this is for the figure 1, but remember it. Now it's the 2024. Actually, you just post all the information. So just I'm going to give all of you here. If you just use the graph or you use the figures or you use any of the statistics, just try to remember to update the newest information on your presentation. Okay. So do you have, no, okay. So thank you so much. About 11 group 2 presentations. All of you are very excellent. Okay, we are looking forward to see the others group to have a presentation. Thank you so much. Okay.
Thank you, professors, for valuable comments and feedback. Today's agenda has come to an end. For tomorrow, we have presentation from 8 fantastic teams, followed by a breakout session where you can connect with like-minded individuals and share